Hello everyone. In this lesson we are going to talk about one important and really interesting topic in computer science where we find application of stack data structure. And this topic is evaluation of arithmetic and logical expressions. So how do we write an expression? I have written some simple arithmetic expressions here. An expression can have constants, variables, and symbols that can be operators or parentheses, and all these components must be arranged according to a set of rules, according to a grammar, and we should be able to parse and evaluate the expression according to this grammar. All these expressions that I have written here have a common structure. We have an operator in between two operands. Operand by definition is an object or value on which operation is performed. In this expression 2 plus 3, 2 and 3 are operands and plus is operator. In the next expression a and b are operands and minus is operator. In the third expression this asterisk is for multiplication operation, so this is the operator. The first operand p is a variable and the second operand 2 is a constant. This is the most common way of writing an expression, but this is not the only way. This way of writing an expression in which we write an operator in between operands is called infix notation. Operand doesn't always have to be a constant or variable. Operand can be an expression itself. In this fourth expression that I have written here, one of the operands of multiplication operator is an expression itself. Another operand is a constant. We can have a further complex expression. In this fifth expression that I have written here, both the operands of multiplication operator are expressions. We have three operators in this expression here. For this first plus operator, p and q, these variables p and q are operands. For the second plus operator we have r and s. And for this multiplication operator, the first operand is this expression p plus q and the second operand is this expression r plus s. While evaluating expressions with multiple operators, operations will have to be performed in certain order. Like in this fourth example, we will first have to perform the addition and then only we can perform multiplication. In this fifth expression, first we will have to perform these two additions and then we can perform the multiplication. We will come back to evaluation, but if you can see, in all these expressions, operator is placed in between operands. This is the syntax that we are following. One thing that I must point out here, throughout this lesson we are going to talk only about binary operators. An operator that requires exactly two operands is called a binary operator. Technically we can have an operator that may require just one operand or maybe more than two operands, but we are talking only about expressions with binary operators. Okay, so let's now see what all rules we need to apply to evaluate such expressions written in this syntax that we are calling infix notation. For an expression with just one operator, there is no problem, we can simply apply that operator. For an expression with multiple operators and no parentheses like this, we need to decide an order in which operators should be applied. In this expression, if we will perform the addition first, then this expression will reduce to 10 into 2 and will finally evaluate as 20. But if we will perform the multiplication first, then this expression will reduce to 4 plus 12 and will finally evaluate to 16. So basically we can look at this expression in two ways. We can say that operands for addition operator are 4 and 6 and operands for multiplication are this expression 4 plus 6 and this constant 2. Or we can say that operands for multiplication are 6 and 2 and operands for addition operation are 4 and this expression 6 into 2. There is some ambiguity here, but if you remember your high school mathematics, this problem is resolved by following operator precedence rule. In an algebraic expression, this is the precedence that we follow. First preference is given to parentheses or brackets. Next preference is given to exponents. I'm using this symbol for exponent operator, so if I have to write 2 to the power 3, I'll be writing it something like this. In case of multiple exponentiation operator, we apply the operators from right to left. So if I have something like this, then first this rightmost exponentiation operator will be applied. So this will reduce to 512. If you will apply the left operator first, then this will evaluate to 64. After exponents, next preference is given to multiplication and division. And if it's between multiplication and division operators, then we should go from left to right. After multiplication and division, we have addition and subtraction. And here also we go from left to right. If we have an expression like this with just addition and subtraction operators, then we will apply the leftmost operator first, because the precedence of these operators is same, and this will evaluate to 3. If you will apply the plus operator first, this will evaluate as 1, and that will be wrong. In this second expression, 4 plus 6 into 2 that I have written here, if we will apply operator precedence, then multiplication should be performed first. If we want to perform the addition first, then we need to write this 4 plus 6 within parentheses. And now addition will be performed first, because precedence of parentheses is greater. I'll take example of another complex expression and try to evaluate it just to make things further clear. So I have an expression here. In this expression we have 4 operators, 1 multiplication, 1 division, 1 subtraction and 1 addition. Multiplication and division have higher precedence. Between these two, multiplication and division, which have same precedence, we will pick the left one first. So we will first reduce this expression like this, and now we will perform the division, and now we have only subtraction and addition. So we will go from left to right, and this is what we will finally get. This right to left and left to right rule that I have written here for operators with equal precedence is better termed as operator associativity. If in case of multiple operators with equal precedence we go from left to right, then we say that the operators are left associative. And if we go from right to left, we say that the operators are right associative. While evaluating an expression in infix form, we first need to look at precedence, and then to resolve conflict among operators with equal precedence, we need to see associativity. All in all, we need to do so many things just to parse and evaluate an infix expression. The use of parentheses becomes really important, because that's how we can control the order in which operations should be performed. Parentheses add explicit intent that operation should be performed in this order, and also improve readability of expression. I have modified this third expression. We have some parentheses here now, and most often we write infix expressions like this only, using a lot of parentheses. Even though infix notation is the most common way of writing expressions, it's not very easy to parse and evaluate an infix expression without ambiguity. So mathematicians and logicians studied this problem and came up with 2 other ways of writing expressions that are parenthesis free and can be parsed without ambiguity, without requiring to take care of any of these operator precedence or associativity rules. And these 2 ways are postfix and prefix notations. Prefix notation was proposed earlier in year 1924 by a Polish logician. Prefix notation is also known as Polish notation. In prefix notation, operator is placed before operands. This expression 2 plus 3 in infix will be written as plus 2 3 in prefix. Plus operator will be placed before the 2 operands, 2 and 3. P minus Q will be written as minus PQ. Once again, just like infix notation, operand in prefix notation doesn't always have to be a constant or variable. Operand can be a complex prefix notation itself. This expression a plus b asterisk c in infix form will be written like this in prefix form. I'll come back to how we can convert infix expression to prefix. First, have a look at this third expression in prefix form. For this multiplication operator, the 2 operands are variables b and c. These 3 elements are in prefix syntax. First we have the operator, and then we have the 2 operands. The operands for addition operator are variable a and this prefix expression asterisk bc. In infix expression we need to use parentheses because an operand can possibly be associated with 2 operators. Like in this third expression in infix form, b can be associated with both plus and multiplication. To resolve this conflict, we need to use operator precedence and associativity rules, or use parentheses to explicitly specify association. But in prefix form and also in postfix form that we will discuss in some time, an operand can be associated with only one operator. So we do not have this ambiguity. While parsing and evaluating prefix and postfix expressions, we do not need extra information. We do not need all the operator precedence and associativity rules. I'll come back to how we can evaluate prefix notation. I'll first define postfix notation. Postfix notation is also known as reverse Polish notation. This syntax was proposed in 1950s by some computer scientists. In postfix notation, operator is placed after operands. Programmatically, postfix expression is easiest to parse and least costly in terms of time and memory to evaluate, and that's why this was actually invented. Prefix expression can also be evaluated in similar time and memory, but the algorithm to parse and evaluate postfix expression is really straightforward and intuitive, and that's why it's preferred for computation using machines. I'm going to write postfix for these expressions that I had written earlier in other forms. This first expression 2 plus 3 in postfix will be 2, 3 plus. To separate the operands, we can use a space or some other delimiter like a comma. That's how you would typically store prefix or postfix in a string when you'll have to write a program. This second expression in postfix will be pq minus. So as you can see in postfix form, we are placing the operator after the operands. This third expression in postfix will be abc asterisk and then plus. For this multiplication operator, operands are variables b and c, and for this addition, operands are variable a and this postfix expression bc asterisk. We will see efficient algorithms to convert infix to prefix or postfix in later lessons. For now, let's not bother how we will do this in a program. Let's quickly see how we can do this manually. To convert an expression from infix to any of these other two forms, we need to go step by step, just the way we would go in evaluation. I have picked this expression a plus b into c in infix form. We should first convert the part that should be evaluated first. So we should go in order of precedence. We can also first put all the implicit parentheses. So here we will first convert this b into c. So first we are doing this conversion for multiplication operator, and then we will do this conversion for addition operator. We will bring addition to the front. So this is how the expression will transform. We can use parentheses in intermediate steps, and once we are done with all the steps, we can erase the parentheses. Let's now do the same thing for postfix. We will first do the conversion for multiplication operator, and then in next step we will do it for addition, and now we can get rid of all the parentheses. Parenthesis surely adds readability to any of these expressions, to any of these forms. But if we are not bothered about human readability, then for a machine we are actually saving some memory that would be used to store parenthesis information. Infix expression definitely is most human readable, but prefix and postfix are good for machines. So this is infix, prefix and postfix notation for you. In next lesson we will discuss evaluation of prefix and postfix notations. This is it for this lesson. Thanks for watching.